In this video and the next several videos, we're going to look at solving various types of trig equations. And in this one, we're just going to start off with a very straightforward and basic trig equation. So let's look at the 2 sine of x plus 1 equals 0. Okay, just like you would any regular algebra equation, just like if you had the equation 2x plus 8 equals 0, here your main goal is to get the x variable by itself, and we would do that by first subtracting the 8 from both sides, and you would end up with 2x equals negative 8, and then we would divide both sides by 2 so that we would end up with x equals negative 4. So over here, we want to do basically the same similar steps. And the first goal is to isolate the sine of x. Okay, so we can kind of think of that as our variable for right now. We want to isolate the trig function sine of x. So that means the first step then that we want to do is we want to get rid of the plus 1. So therefore, we're going to subtract 1 from both sides of the equation, and we get 2 sine of x equals negative 1. And then we're going to eliminate the 2, because that's multiplication. We're going to divide by 2. Okay, so therefore the 2's would cancel out, and we would be left with the sine of x is equal to a negative 1/2. And at this point, this is where we would go to our circle, and we would look on the unit circle. Where do we have a y value? The sine function is y, so where do we have a y value that is a negative 1/2? Well, because it's negative, then that means that we're going down, so we're going to have to be in the third or fourth quadrant. And if we look over here, we'll see that at 7 pi over 6, we actually have the coordinates of negative square root of 3 over 2, and our y value is a negative 1/2. And then also we'll look in the fourth quadrant, and we'll notice here at 11 pi over 6, and at this point we have positive square root of 3 over 2 for the x, and a negative 1/2 for our y value. So here we have two possibilities where our y value is going to be a negative 1/2. So here we have our y value as a negative 1/2. So what we're going to do then is that tells us that for x is going to be equal to either the angle 7 pi over 6 or 11 pi over 6. Now, we want to look at this. If we look at the angle 7 pi over 6 first, let me redraw this here. If we're strictly looking at this one angle for right now, this is the angle 7 pi over 6. And we've mentioned this before, if we keep going around the unit circle, we can keep getting angles that end at this exact same location. So if we rotate simply around here, we get 7 pi over 6. But what if I was to take from here, if I was to add on 2 pi, we would end up right at this same location. And then what if I was to add on another 2 pi? So that means I'm adding on 4 pi. So, and I could keep doing that, or I could go the other direction. I could subtract away 2 pi, I could go all the way around the other way. So here, realize that 7 pi over 6 is not the only answer. We could actually add on any multiple of 2 pi. So we would say we could add on 2 pi, and I'm going to multiply this by n, where n is representing an integer. Okay, so any multiple here of 2 pi adding on to 7 pi over 6 is going to put us at this exact same location right here. So here we're going to have an infinite number of answers for the value of x. So here we have x would be equal to 7 pi over 6 plus 2 pi, or any multiple of 2 pi added on. So that gives us the 2 pi n. And the same thing is going to be true over here for the 11 pi over 6. If we let x equal 11 pi over 6, once again, we could add on a multiple of 2 pi. So we're just going to simply add on 2 pi n. So there's the two answers, or really infinite number of answers, 7 pi over 6 plus 2 pi n and 11 pi over 6 plus 2 pi n. All right, let's try another example. We have the cosine of x minus 1 equals negative cosine of x. Now with this example, we need to be careful. We have, in this case, we have two trig functions, two cosine functions. So just like we did before, we want to isolate the trig function. So here, just like we would before with any algebra equation, we want to move the cosine x over. So we're going to add cosine x to both sides. So we would have cosine plus cosine would be 2 cosine x minus 1 equals 0. And then just like we did before, we want to add 1 to both sides. So we would end up with 2 cosine of x equals positive 1. And then, of course, to get rid of the multiplication, we can divide by 2. And cosine x is equal to 1/2. So once again, we're going to go look at the unit circle. Now that we're looking at cosine, we want to know, where is the x value a positive 1/2? Well, because we're looking at a positive 1/2 and it's an x coordinate, we know it's got to be in the first or fourth quadrant because positive x is to the right. And we'll notice if we go up here to pi over 3, we will have an x value of 1/2. Or if we go down here to the bottom, and this would be 5 pi over 3, we would have an x value of 1/2. So therefore, we would say our value of x, could be equal to the pi over 3. But now keep in mind, if I was to add on, again, a multiple of 2 pi, I could keep on going around. So that would be a multiple of 2 pi, so that's 2 pi n. So we're going to add on 2 pi n. And then, of course, the other angle is 5 pi over 3, so x equals 5 pi over 3, and we could again add on any multiple of 2 pi. So there we have our answer. Now at this point, if you wanted to, you could plug in an integer, a number here for n, multiply that by 2 pi and add it to the pi over 3 or the 5 pi over 3, and again, that would give you additional answers. So there's an infinite number here. All right, the next equation. This one involves a secant. We have 3 secant squared minus 4 equals 0. So once again here, we want to isolate the secant function. So we're going to add 4 to both sides of the equation. And we would have 3 secant squared x equals 4. And then the multiplication, we want to divide by 3 to cancel out the 3. So we would have secant squared x equals 4/3. And now we want to, and I guess there's a couple ways we can do this. We want to eliminate the square. So in order to do that, we would actually take the square root of both sides. And again, that means we would have to put in plus or minus. So that would become secant x equals plus or minus, well, the square root of 4 is 2, so that would be 2 over the square root of 3. Now, a lot of times if I'm solving equations, if possible, once I get to this point, I've isolated my trig function. If I have secant, cosecant, or cotangent, I usually like to rewrite it back in terms of either your sine, cosine, or tangent. So here we know that the secant function is the reciprocal of cosine. So really I could rewrite this secant as 1 over the cosine of x equals, now the plus or minus 2 over the square root of 3. And then of course if we were to work this out, we can actually think about 1 over cosine. If I was to flip this left side, this would become cosine of x equals, and that means I would take the reciprocal on the other side, so that'd be plus or minus the square root of 3 over 2. All right, so now I just prefer to work with either the sine, cosine, or tangent when possible. So now I can think of this in terms of the cosine is equal to plus or minus square root of 3 over 2. So again, we would go to the circle and look at where do we have an x coordinate that we have either a positive or negative square root of 3 over 2. And in the first quadrant, we're going to have a positive here at pi over 6. In the second quadrant over here, we would have 5 pi over 6. And the third quadrant, we would have 7 pi over 6. And then over here in the fourth quadrant would be at 11 pi over 6. And I want to kind of emphasize something here, so I'm going to use a slightly different color. Let me just redo this here. So here we have our pi over 6, 7 pi over 6, 5 pi over 6, and 11 pi over 6. So there we have actually 4 angles where we have a positive or negative square root of 3 over 2. So what that means is now we can look at this as saying, well, x is equal to pi over 6. Now, normally in the past with the other equations, I said we could add on a multiple of 2 pi n. But with this example, I want you to notice something here. If I look at the pi over 6, and then over here we have a 7 pi over 6, notice this green line. These two angles are right across from each other, pi over 6 and 7 pi over 6. So this distance here is actually 1 pi. So that I don't have to write this down twice, for example, instead of writing this answer as x equals pi over 6 plus 2 pi n, and then writing x equals 7 pi over 6 plus 2 pi n, because these two angles are pi, or 180 degrees, they're right across from each other. Instead of having to write this down twice, we can simplify this by simply writing pi over 6 and add on a multiple of pi. Because if I have pi over 6 and I add on 1 pi, that's going to give me 7 pi over 6. And then if I add another multiple of pi, I'm going to be back over at the same location as pi over 6, and so on. So we could just keep going around and around the circle. So we would end up with pi over 6 plus pi n. So then if we look at the other angle here, the 5 pi over 6 and 11 pi over 6, notice here once again they are directly opposite each other. So here if we add on pi, we're going to eventually hit each angle. So here we could add on a multiple of pi as well. And the easiest way to identify this is to realize when the angles are exactly opposite of each other, where you actually form a straight line. All right, let's try one last example, and at this point maybe you've had enough practice you can try one on your own. So we have 3 cotangent squared x minus 1 equals 0. So once again here we want to add 1. So if we do that, we're going to end up with 3 cotangent squared x equals a positive 1. Divide by 3, we get cotangent squared x equals 1/3. And then once again here, we can take the square root, or in this case, once we've isolated this, if we want to go ahead and change our cotangent to a tangent, we could think of this as 1 over tangent squared x equals 1/3. And then this would become tangent squared x equals 3 over 1, or simply 3. So either way we can do this. So then if you take the square root, we're going to get plus or minus. So therefore we have the tangent of x is equal to plus or minus the square root of 3. So now, because this is the tangent, that means we're looking at where does y over x, that's the y divided by x, where does that equal either a positive or negative square root of 3? So once again here we can go to the unit circle, and if you look at the circle, we know that there's kind of a limited number of coordinates, and if we focus on the coordinate that is 1/2 and square root of 3 over 2. So once again here we have your x and your y. So if we were to take the y value, which is the square root of 3 over 2, if we divide that by a half, that's the same as multiplying by the reciprocal, so that would be 2 over 1, and the 2's cancel and we get the square root of 3. So what this tells us, if we're looking for where the tangent is plus or minus the square root of 3, then we're looking for this particular coordinate. Where on the circle do we have an x value of 1/2 and a y value of square root of 3 over 2? Okay, and that's going to occur up here in the first quadrant at pi over 3, and in the second quadrant that's going to be at 2 pi over 3, and the third quadrant down here would be 4 pi over 3, and then in the fourth quadrant that's going to occur at 5 pi over 3. And you're probably guessing this is similar to the previous example. If you notice again that pi over 3 and 4 pi over 3, they're exactly 1 pi away from each other. And the same thing for 2 pi over 3 and 5 pi over 3. So here we could say x then must be equal to pi over 3. Instead of adding on 2 pi, we're going to add on a multiple of 1 pi. And then the same thing for the angle of 2 pi over 3. We could simply add on a multiple of pi. So there we can actually write this as just using 2 answers instead of having to list all 4 of these. Okay, so hopefully now you feel comfortable with solving some trig equations. You have some practice exercises, and then we're going to have a few more videos that look at a little bit different types of trig equations and exploring how we can solve those.